Hello, my name is Chris Baines, and I'm the technical lead of the Client UI Android team at Twitter.
Hello, my name is Nacho. I work in his team. And this is not my voice, this is San Francisco weather. So bear with me a little bit.
So today we're going to be talking about our kind of journey to Jetpack Compose over the past 18 months or so. So in April this year, we worked with Google on a developer story, highlighting some of the kind of benefits and things that we've seen on our journey. And we've shipped a number of features which are actually on your device right now. So community shipped, it's fully built with Compose, and then we also have another screen with Twitter Circle, which is rolling out over the next 6 months or so. And there's more in development right now, it's just they haven't shipped yet. So after the developer story, we had a number of teams at other companies contact us asking how, what do we do to actually migrate to Compose? So migrating to a new tech at like an implementation level is one thing, but doing it across a large engineering team, bringing everyone with you, it's a different story. It's much harder. And in this talk, we'll cover kind of how and why we did it. So before we go into what we did, I think it's important to note that what we did wasn't necessarily perfect. It worked for us, and that is to say that you shouldn't necessarily mimic what we've done in this talk. Do what makes sense for your apps, your teams, your structure, your product priorities. And if you think back to what you did on your journey to Kotlin, the same kind of rules will kind of apply to. Right, so let's start actually looking at what we did. So Twitter for Android is a large app. It has currently just over 1,000 modules of various sizes and complexity. And just like all apps that have like evolved over time, we have a lot of legacy code. Of those 1,000 modules, we have roughly 300 contain some kind of UI, so about a third of them. And all those modules are split between just over 30 teams. Each of those teams is focused on their own sort of part of the app, and they own their own kind of like small number of those modules. Now, 30 may sound like a lot, but it's actually, each of those teams could be pretty small. They could have just like 100 or 200 engineers. So efficiency is really important. That's where Compose is really good. So back in kind of late 2020, our leadership posed the question of how do we make UI development faster? And specifically, that is about like how do we increase like development velocity for feature teams? Like how can they ship faster and more efficiently, whilst also trying to maintain or even increase, if possible, actual quality as well. So that question very quickly became, how do we use Compose? Now, this was before Compose 1.0, but it was obvious that it was going to be like the future of Android UI development. And similarly, the iOS team were doing the same sort of exercise, looking at Swift UI, so it wasn't just us. So we decided to start with a single component, and that was our button. It was kind of good timing because design had recently redesigned the button, like the red line. And it's also got a small component, and it has lots of variations, which Compose is really good at. But when you start using Compose, you can't just jump straight into writing a component. You've got all this theming stuff to do as well. So we, like many companies nowadays, have our own design system. And that provides a set of styles for typography, sizing, colors, and loads of other design tokens. But it isn't a material design system. It doesn't map one-to-one. It's fairly close in some places, but very different in others, even though it may look the same on your device. So our next question was, how do we actually write that design system in Compose? So when you think of Compose, you might think of it as a single thing, but it's actually a number of layers. So at the base is the runtime libraries, and these are fundamental APIs which aren't specific to UIs at all. It's things like state, snapshots, composition locals. It's stuff that, it's all base stuff. And above that, you have the UI layer, and that brings in UI primitives. So touch handling, measure, layout, drawing, that kind of stuff. The next layer above that, which is actually a very large layer, it's called Foundation. And that provides a number of things, but most of the common layouts you use, like box, row, column, lazy column, but also animations and other stuff as well. And then finally, we have the material layers above that. Now, this layer provides an opinionated implementation of material design and material design free. Now, I want to stress a certain word here, which is the word opinionated. The material library for Compose was built for Compose. Built for material. There is no generic theming or styling system in Compose. So everything built in Material, in the Material library, is built with the Material guidelines in mind. So we compare that to views. It's kind of fairly similar if you kind of squint. At the base layer, we have the Android framework, and then above that, we have the view system. That's all the views. But it actually contains some Material concepts as well. You think ripple, clipping, there's loads of other stuff as well. And they were implemented in the view system more for efficiency, more than, say, they couldn't be unbundled into Android X. Then we have Android X and AppCompat, but also things like card view, they're, again, Material stuff. And then above that, we have the Material design components, which is off-the-shelf componentry for Material. So if we compare which of those layers kind of contain Material, you can see that views are much more leaky. Material kind of spreads everywhere, and it's even the default theme on the view system. But in Compose, it's very focused on just one library, and that isn't a mistake. As Roman said yesterday, the Compose team spent a lot of time keeping the definitions between foundation and Material very distinct, and that is to allow a greater, easier way to implement design systems. Now that's great, but it has some knock-on effects for apps. So if we think of a design system in a kind of ratio of 0 to Material, most apps with their own design system will kind of sit in the middle, or want to sit in the middle. And that is because there's no getting away from the fact that Material is the default theme on Android. And so you still want to keep certain elements of Material to make your Android app feel like an Android app. So things like touch highlights, ripples, or sparkle on Android 13, 12. The general structure of your app, the way the Chrome, like top app bar at the top, bottom navigation maybe, side draw. And these kind of things you want to incorporate, but they may not be actually part of your design system. So if you think about how easy it is to implement these kind of sections, I'd say the extremes are much easier in Compose. So if you don't care about platform consistency for whatever reason, and you just want to implement your exact design system, Compose is great. You just build on foundation, and you can build all the layers on top you need, and then you're done. And then similarly on the right-hand side, if you're fully Material, great. Having this really opinionated, cohesive implementation is perfect now, because you no longer have to try and work out which layers you need to use, which APIs are deprecated and be superseded, all this stuff. You no longer have that now. It's just one library, one place to look. It's pretty easy. But the middle bit is actually it might actually be easier in views. And that is because for you to bring in things like Ripple or other stuff that you want to incorporate from Material, you then need to use Material theme. And so as soon as you use Material theme, you need to somehow map your design system into Material. You have this lossy conversion, which may not always work. So when you start implementing your theme in, you've got a decision to make. And that is you either map your design system to Material, which may be easy, may be hard, depends on what your design system looks like, or you just start afresh and just build everything yourself on top of Material, foundation. Now, to give you an idea about what we did, we started off building on top of Material, and we mapped our design system as well as we could to Material. And then we also, the way we did that is by wrapping all of we have our own button, our own text, and we wrap the Material components. And that was great because it allows you to get very fast, very far, very fast, because you're building upon layers which are already very well built, because they're built by the Compose team, but also everything's there already. But then lately we've started moving more towards the kind of layer of building our stuff on top of foundation. And primarily that is by copying the implementation from Material into our own source tree, and then just making modifications as we need. And that is mostly because we've been caught a few times by kind of implicit functionality, such as content color and content alpha. And it just doesn't really work. Those concepts aren't in our design system, and so we just need to remove them. Now, that's all I'm going to talk about design systems. There was 2 talks. Well, one talk was earlier this morning, and then another talk by Ryan later today, which talked about design systems. If you're interested in more, catch those. So we fast forward now to kind of April last year. Compose was just about to hit 1.0, and we had implemented most of our kind of components and theming, and we were ready to kind of start using this for real. Now, you think back, our question was, how do we start using Compose? And that basically turned into now, how do we actually start using this across the app? How do we get feature teams involved and actually start proving that this works? So we decided to create an early access program within the Android team. We found 4 teams who were eager to use Compose. We started out small, as it enabled us to work really closely with teams and give like really one-to-one communication and feedback and collaboration. And the program was very informal, which when we look back now may have been a mistake, because we couldn't set any defined responsibilities or kind of like, that. But we kind of relied on the fact that both us and the feature teams were really involved and wanted really to make it work. And it kind of worked. In terms of how we chose each team, each of the teams was soon to begin writing some kind of UI. Some had like large screens, like whole features, like communities. Some just had single screens. Didn't really matter. The important thing was that we needed different requirements. So some needed lists, some needed navigation, animation, whatever else. And it basically acted as a way to crowdsource our priority list. We couldn't leave those teams blocked if they needed something, so we had to be very flexible and make sure that we were like our time was like free, so we could actually unblock them as quick as possible. But we quickly found out that kind of supporting multiple teams concurrently in close coordination was a lot of work. Now, our team is 5 people, or 6 people, and actually doing that with like one-to-one communications, it takes a lot of time, because we were providing in-depth feedback on code reviews, design docs, creating, as we had questions and answered them, we were trying to create documentation to try and like expand that, and then also trying to fill those feature gaps. So as the EAP team started actually shipping code, like committing it into the repo, other teams started seeing this, noticing, and like, we want to use Compose too. The problem was that they wouldn't usually talk to us before they'd started using it. And so the first time we'd hear about it was we'd get this code review, which is like, how does this work? What's this issue? And then we'd have to then spend a week or two actually then going to help them. Now, because we didn't know about it ahead of time, we couldn't plan the time, and so we just ended up getting slammed, basically. And as you can imagine, there comes a point where just supporting many, many teams just kind of hurt us, and it kind of overwhelmed the amount of support we could give. Now, that animation was an exaggeration, but it gives you an idea. So by this time, it was about December last year, and that overarching question became, how do we spend less time supporting teams? We'd built most of the components, and we're getting that point now where we're like trying to productionize it. So we came up with 2 kind of programs to help us move forward. The first was an allow list. And quite simply, that was just a list of Gradle modules, which we said could use Compose. And that may sound kind of archaic, like stopping people using stuff. But teams could request to be added to the allow list. We just had a number of questions. We wanted to really open the communication stream before they started using Compose. And we'll see those questions in a minute. But it enabled us to find out what support they needed, but also what support we could give them. So it just opens that communication channel. So the allow list, the actual mechanics of the allow list are pretty simple. It's just a bit of Gradle. This was running every Gradle module in our code base. So we just have a list of this text file that contains just module paths. So we read that, and then we just check if the Compose compiler has been run. If it is, and they're not in the allow list, the build gets an exception is thrown, and the build fails. If you want to know more about this, there's a link there. You can just copy it in. So the questions were pretty simple. There's 4. Can you spend the time to learn Compose? Like, Compose is a mind shift change. The move to declarative UIs is not an easy one, and it does take months, maybe, for it to really click. We don't want it to be just someone hacking around for a week, shipping stuff, and then it can't be supported. Next question was, can you iterate on our feedback? If we were going to spend the time really helping you, code reviews and design docs and all the rest of it, are you actually going to listen to it? Well, not listen to us. Are you going to actually communicate with us and actually help yourself? And the next one was, what features do you need? Like, if you tell us that, I don't know, you need, say, emoji and text, Sean, and we know that it's not available, we can tell you ahead of time and maybe give you an alternative or a workaround. And the same thing, if there's a feature that we need to provide, which we haven't done yet, we can maybe up the priority and actually do it as quickly as possible. And last one is your whole team on board? What we found is that we tend to have individuals that just wanted to start use Compose, but the rest of their team didn't. Now, our team, Client UI, didn't want to have to be reviewing everyone's Compose code for the rest of time. We want each team to be self-sufficient, and then we can expand from there. And the second idea was the Shepherds program. And it's quite simply, this is a work in progress, this isn't done, but it's an idea that we have. And that is a group of engineers there to shepherd Compose adoption within Twitter. What currently happens right now is that the shepherds are automatically added to every Compose code review. And then we don't expect them to review everything, but it's to keep an eye on like trends and missing features. And the goal at the moment, the shepherds is just our team. We want to expand it to other people. So the prime thing we're looking at right now is the EAP teams that we've brought on board over the past year or so. Bring them in and actually expand it across more than just our team. So if you fast forward now to today. So currently we have roughly 60 modules using Compose. So if you think back, we had 300 UI modules, so we're about 20%, 25%, which I don't think is too bad. We have 13 teams using Compose, and more trying it out as we speak. Right, I'm going to hand over to Nacho now to talk more about the actual integration.
Okay, so hi. So I'm going to talk to you about the developer experience of using Compose at Twitter. So apart from big, what Chris mentioned a couple times, the code base is very long-lived. So the first commit is from 2010. And that leads to that there is a lot of custom infra that has been created over the years. And a lot of it was created even before there were viable open source alternatives to it. So yeah, we have a lot of custom infra. So I'm going to talk about two tiny examples of what I mean with this. We have a UI framework called Weaver that manages two things: two-way data binding and view models using MVI, and not based in architecture components, not tied to Android at all. And we have a soon-to-be open-source AI framework, fully featured, that's called Scythe. You can think of it as Hilt meets Anvil meets objective-oriented programming principles. It's pretty cool. But the thing is, all of this custom infra that we have, if it's close to the UI, it has to be properly supported in Compose. So for example, our UI framework has composable extensions to be able to acquire view models, interact with the state, has effect support, etc. And our DI framework has composables that allows us to acquire dependencies from within a composable. So the thing is, Google provides some magnificent documentation for Compose. It's amazing. And of course, that's the first set of docs that we're recommending people to use. But we have a ton of custom infra. So we had to create an internal hub of Compose-related documentation sitting on top of the Google Docs to explain how this custom infra could be used inside of Compose. So if we are speaking about properly documented, there are a couple of archetypes here of engineers that we stumble upon. Either they are new to the company, we were on a hiring spree last year, and also people that have experience, but they are brand new to Compose, that they haven't been like us working from a couple years ago, but they are curious about it. So the thing is, apart from providing primers and reference materials for this custom infrastructure, we had also to cater documentation for all levels of knowledge. So for people starting to onboard to Compose, independently of seniority level, tenure, whatever, we found great value in code labs. So for example, we have one that teaches people how to create a new screen from scratch, kind of from zero to hero. It teaches you how to create the DI setup, how to interact with these view models I was talking about before, and how to build a screen based on that data. But when you're in the heat of it, writing composables left and right, you are pretty likely to hit some walls. So we want folks to know we got their backs. So we have a whole section dedicated to things that have been proven to be common pain points or blockers. So Chris was joking about this, but using custom emojis is not possible yet. That's kind of a big deal for us. Interop performance when using a compose view inside of a recycler view, it's kind of like, And if you are doing like complex accessibility experiences, the support is limited. It's like, it's good, like for 99% of the cases, but imagine tweet view, like that's a big one. And others, like we keep adding things as we stumble upon them and to provide like good solutions for people. So when you start working on Compose, up until it starts to click for you, and you become proficient, and then you are top of the world, there is a big steep learning curve. And ideally, you would want some guidance to make sure that you're doing things in the best way possible. So that's when things like best practices, style guides, etc., like they come really in handy. But we are all in the process of learning here. Compose is quite new, it's quite comprehensive. So how can we start writing this kind of document if we don't even know what issues are we going to find or what is the best way of addressing them? You could have an intuition, but you don't know. So the thing is, like, we will circle back to this in a couple of minutes, but spoiler alert, our solution involves tooling. So yeah, it's involved. So the thing is, documentation was a big investment for us during the road to general adoption of Compose in our app. But even a bigger investment is to be able to get people onboarded faster. And for that, we have seen that tooling works for us, extensions on the infrastructure works for us. So we use a bunch of different tools for this. Let's start from the first one. Let's start with Compose previews. So previews are very helpful. They allow you to see what you're doing with your code. And they are especially useful when you are starting with Compose. But previews are typically picky. So the thing is, like Bumblebee, Chipmunk, it didn't work for us. Like 0 previews were rendered during those times. Starting from Dolphin, it has become better, and we are able to use them. We have a couple of teams that mainly work like this. So to use previews, you either have to, at the moment of today, you have to use the beta or canary channels and use those Android Studio versions. Also, in our app, we maintain not 2, but 3 different themes. So we would like all of these to be supported out of the box in previews with no extra works for devs. We define them with an enum. And the thing is, like, we have the preview parameters providers for those. They are quite handy. And creating one of those, like for things like this enum I was showing before, is like super simple. It's a one-liner. So you would inject that in a parameter in your composable, and it would just work. But the thing is, there is only one that's allowed at the same time. So we created our own composite preview provider. There's a gist there if you are curious. But the thing is that allows us, out of the box, to have support for themes and whatever the team needs. So for example, if you have like a view state or whatever that you want to provide different versions of it to be rendered automatically in your previews, you can do that. Like we would use a pair or a tuple or whatever to be able to feed you all the possible combinations of that data. And it's used like this, like, pretty simple, like you provided a bunch of preview providers and we create all the combinations for you. So let's talk a little bit about how previews work when you control a bunch of custom infra, like I mentioned that we do. Because previews, they run on their own activity, and we don't control that activity. It's a pretty bare bones activity. So if we take a look at the custom infra composables we've seen before, and a couple more that I threw for no reason, they don't, they have to not crash. They must not crash, because if they crash, the preview just doesn't work, and Android Studio is a bit flaky. But why would they? Why would they crash? Well, if you have close ties to DI, or you are making assumptions on which base activities you are going to find out because you don't control them, you are in for a ride there. And this is how many of our custom infra composables work. So how can we keep it? How can we keep them from crashing? Well, we can create fake implementations for them. So we can know if we are in a preview by using a composition local called local inspection mode. It's a Boolean, and if it's set to true, it means that you are in a preview. So if that happens, you can, in your infrastructure composables, you can provide defaults. So for example, this is how we define which font to use. Like in the Twitter app, we're using a custom font called Chirp. And there was, initially, there was a big if. There was like, if this feature flag is set to true, we are going to use Chirp, else we're going to use the default. But with this composition local, with local inspection mode, we can provide you with a sensible default out of the box. The feature flag code doesn't need to run at all, and your preview will look at its best. For an even faster feedback loop, we've been experimenting a little bit with live edit ever since it was announced at I/O. And to be honest, like in the past, we've been hyped by similar approaches, but none of them really work in Twitter for Android. So, but however, live edit, like it's showing a ton of promise and mostly kind of works. It's a little bit crashing my crash face, but it will likely get better. Like we've seen some improvements, and like the feedback loop is like pretty fast. So I want to believe that this is this will be a good thing for the future, I think, to take on. But yeah, looks very promising. And I want to talk a little bit about feature parity with views, and it's not quite there yet. But we have Android views for that. So some of the problems that I was talking about earlier, they can be easily solved with using an Android view fallback. So when you start with Compose, using an Android view composable kind of feels like you're being defeated, you're admitting defeat. But once you shake that feeling off of you, like they are actually necessary as of today. There are some cases, like I'm going to talk about, in which we needed to use Android view. For example, text for custom emoji, text fields with custom emoji, and also, like for example, imagine in DMs, if you're like searching for a GIF in your keyboard, and you want to insert that GIF in the DM, we want that. And also, tweet view, as you can imagine, is like the cornerstone of our app. It's a modular view collection. It's pretty big. The thing is, like, it can be like, because it's very modular, some parts of it could be migrated to Compose, while some parts are still not migrated to Compose. So it's like, it's a good use case for this as well. So let's focus a little bit on text, because custom emoji support is not supported by text composable, but it is really important for us. So we have our own open source emoji collection. It's called 2emoji. And it's used everywhere in the app, both in text and text fields. So what we did, we created a text composable facade. And to decide which one to use, whether this Android view wrapper or the text composable, we decided automatically via some heuristics. We allow for people to force the wrapper if they want so. And we use the original text composable as a fallback. And our facade shares a very similar API with text. So about those heuristics I was talking about, we want to decide automatically if we want the wrapper or not. So we have like a method that returns a Boolean. But what it basically does is it looks at the string and detects if there is an emoji there. And if there's not, we're going to show you the composable. For the API, in this case, it's similar, so that when Google releases support for custom emoji, we can reevaluate and like swap it, and everybody uses a composable now, and we're good to go. Also, we allow people to force using the wrapper if they want. Like we added like a forced text view boolean there. If you're interested in how the wrapper works, which we have a GIS there, but it's quite interesting because we have a ton of code to map the styles in Compose to the styles in the view. It's not very apparent how to do that, but we managed to do something that works. And as I was saying, that the composable would be always used as a fallback. Okay. So Jim, he's the progenitor of Compose, as it says in his Twitter bio, says that it usually takes a bunch of months to get to a good spot. But until then, until that happens, it's an uphill battle. The learning curve is very steep. So the thing is, like, what we found when onboarding people to Compose is that nobody starts at the same page. Like, there are some people have weekend projects, some people just don't. It's fine. And it's very easy to make mistakes, like, and they are not apparent, and they can sneak in like at any point. So at the beginning, as Chris was mentioning before, it was just our team, the client UI team, taking care of all of the code reviews for all of the Compose code while everybody was ramping up. And for a team of 6 engineers at the time, it averaged around 15 hours of review time per week, which is a lot. And those first reviews, they were always absolute madness, carnage. It was like lots of comments, 30, 40, like it was impossible to follow Fabricator. And we found, like, we noticed that there were like, most of them were pure bike shedding. And a lot of them were trying to get people to work in a more of a declarative way. And we also find potential bugs, code that wasn't recomposition friendly. And bike shedding gets super annoying super fast. The uptime time that you have to tell people, hey, put the modifier as the first one of the parameters that have a default, no, it sucks. So you just don't have it in you to provide the full explanation again. So as you might imagine, that wasn't sustainable at all for us. So we went all in creating static checks because it made sense. It was the best return of investment possible. Like, we will spend quite a bit of time doing that, but you do that once and it's done. Like, it's a non-issue. And it helps us with having less time in reviews, and it was also very good for feature teams because their patches stayed less time in review. And they scale really well. So it's a machine doing the work, right? Like, it doesn't matter the number of people submitting code. Like, the 20-second time that you explain something, you're not going to be very articulate, and you won't be in a teaching mindset. You would just be annoyed. So it helps with that as well. And also, like, you can craft really good error messages to make them a teachable experience. And for that, we use a little bit of lint, but mostly in our case it is Katy-lint. I'm going to throw a little disclaimer here because I got a lot of flag when I said that we were using Katy-lint for this. But Katy-lint works really well for us, and we were already using it in the code base for similar purposes. However, you can use detect, lint, custom IntelliJ plugins. It doesn't matter because in reality, when you're writing one of these Katy-lint rules, you are interacting with PSI element, with AST node, with Katy files. It's all the same. So porting custom rules from one to another is quite easy. As to why it works well for us, well, it has custom rules, it has autofixes, so check. And Lint has been not treating us very well over the years, so we are a little bit worried and suspicious of it. But every time that there is lately it's been better, but every time there was like a big HTTP update, lint would be broken for months for us, which meant like a ton of modules where lint was not running because we needed to keep the release train going. It is really fast and enables us to run it in pre-commit Git hooks. And it has a great IDE plugin, which is unofficial, but it works really, really well, and you can provide a custom rule set if you want it. So let's see some of our custom rules. For example, we have one that detects that composables, that emit layouts, that we should add a modifier to them, and you can refer to Chris's blog post about it, about more information as to why. But speaking of modifiers, reusing them is bad. It will create some unintended chaos in your UI as soon as you provide one externally. We've seen this happening a lot. We also have another one that makes sure that composables don't emit content from multiple composables at the top level. Because this creates an implicit dependency. If you take a look at this very simple composable, if you wrap it in a column or you wrap it in a row, it's very different, the UI that you're going to get. So a rule forces you to either define a top wrapping composable or making an extension function of row scope, column scope, etc. We also have one that makes sure that composables that emit content don't return a result as well, because you either do one or the other, like don't do both at the same time, because it is a mess. And also, as we were passing by, we also made sure that adding to that rule that a check to check that the composables that emit content always return unit. We also detect, and this was a very sneaky one to detect, but we detect if composables use non-mutable types as parameters, because we should avoid mutability in params as much as possible. We have an allow list for common platform mutable types, like let's say array list, hash map, hashset, etc. And also one for compose for the mutable state class, because that was the #1 by far that we saw in code reviews. People were just like, I don't want to hoist the state. I don't want to use lambdas. I'm going to just throw this mutable state around, see what happens. This also was like a very sneaky one that's, it was in our code a couple of times, even in our platform code that we did, and it was very easy to miss. So when you're using mutable state of or derived state of, when it is inside of a composable, you should be remembering it. Because this way you avoid potential issues with the state itself and have it recreated in recompositions when you don't want that to happen. Let's talk a little bit about view models. So for example, like in our case, it's not called view model, it's Weaver view model, but it's all the same. We detect if it's acquired in a function body of a composable. Because doing that is not ideal. So we prompt it to inject it as a default parameter. Because this way we facilitate testing, so people testing this composable can inject their fakes directly. And reusability, because like you can provide this composable, the view model from wherever, like you don't care. And we actually enforce the same type of behavior for other composables in our infra, like dependencies acquired from site, for example. But we can extract from that a more general rule, which is like any implicit dependency that the composable has, it should be made explicit in its method signature. We also have one that detects if you are forwarding around view model instances. Because it's not recommended, because it means that the initial composable that's going to be stateful makes another composable stateful too. So instead, we can do the same thing by using hoisting, right? And we take what we need, we send any event backs from the other composable back with a lambda, and this way we kind of keep in check the proliferation of stateful composables. We want, like at most for a screen, like one stateful composable, and then like all the rest stateless. So we wrote the rules first, and based on issues that we were seeing in code reviews. And we created our best practices that I was talking about around these custom rules. So then, thanks to that, we were able to expand the error messages for those rules, added links to the docs. So we created a feedback loop there that was quite useful. People, when I tweeted about this, people were interested in open sourcing. So we're working on it. Going to talk a little bit about testing. I'm going to speed up, don't worry. We use Roboelectric, we use JVM tests, very little device tests, and writing comprehensive UI tests is tricky for us. But Compose tests still use Roboelectric, still JVM. For Android views, we can use Express on top. And we use screenshot tests for peace of mind. So for that, we use Paparazzi, which today hit 1.0 milestone. And the thing about Paparazzi is it doesn't like Roboelectric. We have like some customizations on top, so we auto-clip transparency from those renders to save space. We add borders around the components, so this magenta border, like it makes it like more easily visible. And our Paparazzi composable runs with local inspection mode set to true. So our developer experience, docs available for all levels, previews have to keep consistently working. We use Android View when we need feature parity. We use static checks to scale adoption, and you need a screenshot test for making sure everything is fine. Well, so we don't have time for the last section, so yay. I wanted to show that.